In this lesson, we're going to determine if two lines are parallel or perpendicular, and then we're going to write an equation for lines that are either parallel or perpendicular to a given line. Two lines are parallel if and only if they have the same slope and the lines never intersect. Lines are perpendicular because they intersect to form four 90-degree angles. Those two perpendicular lines also have slopes that are negative reciprocals. All right, guys, let's quickly review what a parallel and perpendicular lines are. So if you see in this particular example, the parallel lines, line A and line B, they run side by side, they never intersect, and they both have the same slope. You can see here the m value is 3. So we could write it and say that line A is parallel to line B. Okay? So the lines never intersect and they run the same distance apart no matter where in the line you compare the two. When you look at these perpendicular lines, you're going to notice a couple of things. In this case, the slope value, they are both negative reciprocals of one another. The second thing you're going to notice is that there are 90-degree angles here. There's 1, there's 2, there's 3, there's 4. Those are 90-degree angles, okay? 90 degrees. And they intersect exactly at that 90-degree point. So we can say that line D here, okay, line D is perpendicular to line C. All right, so there's a quick review, and this is how you would write it. Line D is perpendicular to line C. Line A is parallel to line B. Okay? Let's go ahead and take a look at some examples now where we are going to attempt to write equations for lines that are parallel and equations for lines that are perpendicular. All right. The first example I want to take a look at here is this. So I'm going to give you two equations for a line, and you're going to tell me whether they are perpendicular or they are parallel, or third option, they are neither. So one of the examples you're going to see in your homework looks like this, where they'll give it to you in slope-intercept form, and they'll also give you the line in standard form. So the first thing you're going to have to do is take this line that's in standard form and convert it into slope-intercept form, just to make things a little easier. So what I'm going to do here is I'm going to divide both sides of the equation, everything in both sides of the equation, by 5. And what I'm going to get is this. Y equals 10 divided by 5x minus 5 divided by 5. And of course, we know that that simplifies down, okay, to y equals 5 goes into 10 twice, and that's 1. Okay? So now what we're going to do is we're going to look at this equation and this equation. Okay? We're going to compare the two equations, and we're going to determine whether or not they are parallel, or they are perpendicular, or they are neither. So I'm going to look at the slope here, okay, in both instances. The slopes are the same, okay? Because slopes are the same, okay, we know that both of these lines are going to be parallel. Okay? So in this case, both of the lines are parallel. All right, let's look at another example. Okay? And I just want to remind you that slope-intercept form, okay, this is just a reminder, this is a tip, if you will. All right? This tip, y equals mx plus b. Okay, remember that. That's how slope-intercept form is written. The m value here is slope. Okay, that is the slope. And if you think back, you remember what the b value is? That's right, the y-intercept. Okay? Just a reminder, just a little tip to kind of brush the cobwebs away from sitting around at home. A little inactive right now, but that's a tip. Okay, let's look at the next example. Let's choose something a little different. Well, I don't know if it's a little different or not, but y equals 1/3 x minus 3, and then x plus 3y equals -3. All right. Well, this line is already in slope-intercept form, so let's take this one from standard and turn it into slope-intercept, okay? So the first thing I'm going to do is subtract x from both sides of the equation. That's going to leave me with 3y minus x minus 3, okay? Then I'm going to divide everything on both sides of the equation by 3, and that's going to give me -1/3 x minus 3 over 3. And that goes ahead and simplifies to this. Okay? So now we have two lines. Here's the first one in slope-intercept form. There's the other one. And what I'm going to do is I'm going to compare the slopes. Okay, there's a slope here. There's a slope. Now, as I look at them, the only thing I notice is this one's positive, this one's negative, but they're not reciprocals, and they're not the same. So in this case, it's neither. It's neither parallel or perpendicular. Okay? So let's take a look at another example of something you're going to see in your homework, or the problems that I'm going to give you. So I'm going to give you another scenario where I give you the equation for a line, such as this. And then I'm going to give you a point. Okay, here's an ordered pair. And you know that this is the x value and that's the y value. And I'm going to say, write me the equation of a line that is parallel to this line right here, but it runs through this point. Wow, okay. So I need to write an equation. Okay? And the equation of the line that I'm going to write has to be parallel, okay? So it's got to be parallel. And you're right. You caught that. I caught it right after the fact. Parallel. I spelled parallel wrong. Okay. So let's start with that. First thing I need to determine is what the slope of this line is going to be. Well, if it's parallel, doesn't the slope have to be the exact same? So I know that for this line, the slope is also going to be -1/6. So I'm going to take this information here, and I'm going to plug it in to this particular formula. It should look pretty familiar, right? So I'm going to take the y minus y1, which is this y value here, equaling m, which is a -1/6, times x minus 2. All right? I'm going to go ahead and simplify. I'm going to distribute the -1/6 into the values here. I'm going to get a -1/6 x, and a negative times a negative is positive 2/6. All right? And let's go ahead and simplify this 2 more times, or at least 1 more time here. 1/3. And then I'm going to add 1 to both sides of the equation. And yes, you need to show all your work. Okay, please, guys and girls. And here's what I got. So this line, okay, the line that I just came up with right here, is parallel to this line. And I know that because both the slopes are the same. Okay? And this line also goes through this point. So both of these lines are parallel. And this is the equation of a line that runs through this point and is parallel to this. Okay? Let's do one more example that is sort of like this, and then I will go ahead and give you your homework. Okay? Now in this case, in this example, I'm going to ask you to do both. I'm going to ask you to write the equation for a line that is both parallel and perpendicular to y equals negative 9x minus 7. And it has to go through this point. Okay? Again, that's the x value, that's the y value. So I'm asking you to write an equation, okay, of a line that runs through this point, and I want one that is parallel, or excuse me, perpendicular, and I want one that's parallel. Fine. Let's start with parallel first. So if it's parallel, the slope is going to be the same as this, okay, which is negative 9. If it's perpendicular, the slope is going to be a negative reciprocal, or 1/9. All right, so let's first write the equation for a line that is parallel. Okay, so I'm going to start with that one, and we'll do that right here. I'm going to take this formula and plug into it. Okay, this should become second nature to you at this point. Plug in the y value. Now notice it's a negative 1, so y minus a negative 1. Slope is going to be negative 9 because we're writing the equation for a line that's parallel. And the x value is going to be 9. Okay, and that's where I took it from. So let's simplify this. And again, I am taking this negative 9 and I'm distributing it to the contents inside the parentheses. And negative 9 times negative 9 is a positive 81. Then I'm going to subtract 1 from both sides of the equation, and I am going to get this. Now remember, a negative 1 combined with a positive 81, the signs are different. Keep the sign of the larger absolute value and subtract. So here we go. There is the line that is parallel to this and runs through that point. Okay? Now we're going to do the same thing, except we're going to figure out the equation of a line that is perpendicular that runs through that point. That is perpendicular to this line and runs through that point. So again, I can use the same formula. All right? And I'm going to plug in y minus a minus 1, or a negative 1. The slope in this case is 1/9. And everything else is the same, minus 9. Okay? Let's simplify. Again, I am going to distribute the contents, or distribute 1/9 into each of these. 1/9 times x is 1/9 x. A positive times a negative is negative 9/9. All right? So let me simplify so you can see what I'm doing. Right? And then I'm going to subtract 1 from both sides of the equation, and I get this. Okay? So, what have we done? Just in review, we went ahead and came up with the equations of a line that is parallel to this line and a line that is perpendicular to this line. You see here, it's a negative reciprocal of this line, so we know that they are absolutely perpendicular, and this line runs through that point. And this line here, you can see that the slope here is the same as this one, and it runs parallel to this line and runs through that point. So hopefully this is helpful in you working your way through your homework. Again, you'll get a chance to comment and ask questions after you look at the answer key for tonight's homework. Make sure to show all your work or you will not get credit, or worse, you'll have to redo the work. I went ahead and put the homework handouts here for you in this video. Make sure to copy it down and show all your work. Till next time, thanks for watching.